Hi everybody, in this update we're going to talk a little bit about the materials I use in 3D printing and some experimentation I've been doing. A couple of months ago you saw that I printed each of these different materials so I could test them in sunlight. This is nylon impregnated carbon fiber. This is the ABS, ASA, and PETG. These now have accumulated 60 days of sunlight where I've set them out all day out on a bench in my backyard. And as you notice, when you put ABS and ASA back to back, there's no, okay, it hasn't deformed from the sun or anything. So about 2 months ago, somebody trolled one of my blogs and said that I was a phony, a fake, an amateur because I was still using ABS and ASA is the only material to use. Well, I call BS on that. Total BS. Keep in mind, ASA is designed, well, not designed for, but one of the nice things about ASA is it's not susceptible to sunlight. So it can be exposed to what's called chronic sunlight, which is continuous sunlight. Okay? But ABS, for our model airplane industry or hobbies, can easily be exposed, 2 or 3 days out of the week for something like 40 years if you go by the same standards that ASA is. So it's not going to have a problem in our hobby, the ABS. ABS is a little bit less money. ABS melts much easier in the acetone vapor bath. But where ASA is nice is it's a little easier to print. It prints at a higher temperature, so it won't get softened as easy with high heat situations. It really is the only thing about ASA that's different from ABS for what we do is it's a little bit more expensive, but it does have a little bit more heat resistance to temperature. But this BS out there about ABS is obsolete, it's junk because ASA is designed for sunlight. It's for chronic sunlight. If you're going to put ASA in the sunlight continuously for like 5 years, it's probably going to be fine. ABS after 5 years, guess what? I know a friend that built a little fork connector thing that goes on the end of a broomstick to hold up one of his trees. He printed that 5 years ago with ABS and it's still fine. But in a scientific test cell, ASA is much, much more resistant to UVA than ABS, okay? But I call total BS on anybody who says that ABS should not be used, because I do almost all my stuff with ABS and it turns out great. And that guy that trolled me has some kind of deep mental issue because he went ballistic on me about why I should only be using ASA. And that's stupid. Because PETG, you can't affect this with acetone or most chemicals. So you might have a situation where you've got grease and oil and things around it and you don't want it to be impregnated by those different solvents. PETG is great for that. So ASA is great for high temperature. ASA is great if you really want less of the warping when you're printing, because my ASA doesn't warp as easy as ABS. But as you know in my other video, if you use the glue stick right, ABS isn't going to pull up, okay? And the nylon impregnated carbon fiber, this stuff to me is like almost like titanium in the 3D printed world, because the nylon is a very high temperature, very strong, holds up well to just about everything. Being impregnated with carbon fiber is only to make it look cool, because it doesn't make it any stronger. It actually makes it a little bit weaker. So, but yeah, that's where we're at on that. Now, what I want to talk about now is, I read an article the other day that only 25% of people who buy 3D printers change the nozzle size. Most nozzles that come in the 3D printers that we all use are 0.4 millimeter, almost a half a millimeter, so 0.4. what they don't realize is, depending on what you're printing, you can easily go up to a bigger nozzle. Now, what's really nice about that is, imagine that when your printer's printing, and let's say it's going to print a circle, and it takes 30 times to make that circle before it's done, okay? Or if it's printing it this way, that circle. With a wider nozzle, it's going to take a 0.8 will take half the time. So let me look at my notes here. These two, from where you're sitting, probably look pretty similar, but I'm going to put up over here what they really look like up close. Structurally speaking, the one printed with the wider nozzle is stronger because it's putting out more material that's truly melted together, not just bonding. So imagine you've got two pieces of printed material that are 0.8 millimeter side by side. So you end up with, what is that, 1.6 millimeters wide. But if you did it with 0.4, it'd take 4 passes. So the true melted material would be half that width. But what's really cool about this is that this one right here, printed with a 0.8 millimeter, only took 39 minutes to print. This one here, the 0.4 millimeter, took an hour and 30 minutes. So there's a huge savings in time. I've been experimenting this on my large 3D engines because it takes so much time to print these cylinders because there's a lot of material in there. But here's another cool thing is you can normally go to about 80% of the width of your nozzle. So if you have a 0.4 millimeter nozzle, I go up to 0.3 for my height, okay, which is, I know, only 75%. But, and I've actually gone to 0.34 before. But with a 0.8, I can go up to 0.6. Now, you are going to lose some resolution in how things look in curves and stuff. But if you are printing larger parts, and especially if you're going to acetone vapor bath and smooth them, you can cut your time in half, if not by a little bit more than half, by going with a wider nozzle. So right now the experimentation I'm doing is using my standard 0.4. I am going to order a 0.2 just for very fine stuff like instruments I'm trying to work on and cockpit stuff. The 0.4 is what I've been using for the last year. I've got a 0.6. This was a 0.8. But I want you to think about the different things you can do with your 3D printer to make it fit your use. When I go to print something small like this guy here, I might want really delicate corners and it to be very, very smooth. So I might use a 0.4. A 0.2 would take forever. I have ordered one, but I'm just going to use it for little bitty things because that is just a really small nozzle. But if you're going to print larger things, maybe this fan, okay, this fan wouldn't care if it was printed with a larger nozzle. Some of the parts on this engine block here wouldn't care. These rubber tires that I'm developing, which are top secret and I haven't told anybody about, but I'm not even going to show you how up close this is, but maybe from there you can see this tire. I have been experimenting with 3 different grades of flexible material, and it's been the biggest bitch of everything I've tried to figure out with 3D printing. But this flexible stuff, you have to print it really slow, you have to get your layer heights right. You better make sure that you're not borderline schizophrenic or something when you start doing hollow rubber tires like this. And I had another one up here. I don't know what happened to it. Or I play with these a lot lately, just goofing around. But I'm experimenting with making scale tires. This was going to be a scale tire. I've got a friend building a 170-inch wide B58 Hustler. Yes, 178 inches B58. And he wants me to design the landing gear and the tires for him. So this was a very small first experiment on a wheel for a Hustler, B58 Hustler. And that's it for this video. I just wanted to let everybody know that it's total BS about the ASA being the only thing you should be using, and ditch ABS. I'm going to continue the rest of this year, let this sit out in the sun each day and see what happens to it. The layer heights versus the 0.8 and the 0.4. And I guess I'll do a video pretty soon on what I'm experimenting with these hollow tires, and we'll go from there. So I hope you enjoy my videos. Keep the emails coming. I'm trying to answer them as fast as I can. I do not like to chat. So all my friends on Facebook that try to chat and have conversations with me at night, I don't have time for that. If you really want to talk, you know, send me your phone number, and maybe we'll get on the phone together. But all of my followers on Facebooks and all the different groups I have on Facebooks, I don't chat. So when you send me the waves and the things like, hey, what are you doing? I don't sit around and chat. If you send me a private message and say, hey, Damon, I've got an idea for an engine. Can you help me? I'll normally respond to that and tell you to email me. I do 99% of my communication from email. So thanks for watching my videos. I hope you find them informative. And give me more ideas on videos you want me to make. I've got about 12 videos right now that's in the queue, and I'm trying to get caught up. Thanks a lot, everybody. Have a wonderful day, and be safe.